What if we could hold a piece of the solar system's past in our hands long before Earth had life? Before the planets settled into their orbits, there was a small world called Vesta. It's not a planet, not quite an asteroid, it's something in between. And thanks to NASA's Dawn mission, we can finally uncover its story. Let's explore what this ancient survivor reveals about how our solar system was born. In 2011, astronomy experienced a moment that had been centuries in the making. For over 200 years, humankind had known of the existence of giant asteroids in the belt between Mars and Jupiter, but to us, they had always been little more than specks of light in the night sky, tiny dots that hinted at something larger yet remained elusive. The story began in 1801 when the first asteroid Ceres was discovered. At that time, astronomers actually added Ceres to the list of planets. A year later came Pallas, and then Juno and Vesta. For a brief moment in history, our solar system contained 11 recognized planets, the 7 originals from Mercury to Uranus, plus these 4 newcomers. Remember, Neptune hadn't even been discovered yet. But as the years went on, and more asteroids were found, it became clear that we couldn't keep calling them planets. Today, millions of asteroids are catalogued, scattered in a belt that is vast, thinly populated, and endlessly fascinating. Yet, even with this abundance until 2011, not one of those original 4 had ever been seen up close. That is where the Dawn spacecraft entered the picture. Launched in 2007, Dawn was built for a unique task to visit not one but 2 different worlds in the asteroid belt. Its mission began with Vesta, and later it would move on to Ceres. This was a daring idea. No spacecraft had ever orbited 2 separate celestial bodies before. So what makes Vesta so special? Let's take a closer look. Vesta is a world caught between categories. At about 500 kilometers across, it's far too small to be considered a true planet, yet far larger than most asteroids. Its surface area is about the same as Pakistan, roughly 800,000 square kilometers. That may sound large, but in cosmic terms it's tiny. If we compare it to our moon, Vesta looks like a fragment, a shard of what could have been. And yet despite its modest size, Vesta contains nearly 9% of the total mass of the entire asteroid belt. That fact alone helps us appreciate how spread out and diffuse the asteroid belt truly is. Looking at Vesta, you immediately notice its unusual squashed shape. Why isn't it round like a planet? Or even like many of the larger moons? The answer lies partly in its size. It isn't quite massive enough to pull itself into hydrostatic equilibrium, meaning its gravity cannot fully smooth it into a sphere. But size isn't the whole story. The real drama lies in Vesta's violent past. Over 1 billion years ago, Vesta was struck not once but twice near its south pole. Each collision involved planetary-scale objects. The results were transformative. These impacts gouged out craters so immense that they reached all the way down to Vesta's mantle. Today, the most prominent of these scars is called Rheasilvia, a vast basin covering the southern hemisphere. Its terraced walls ripple outward in colossal troughs, dwarfing the Grand Canyon on Earth. And at its centre rises a massive peak, once believed to be the tallest mountain in the solar system. Later measurements gave that crown back to Olympus Mons on Mars, but Rheasilvia's central peak still towers 20 to 25 kilometres high and stretches over 100 kilometres across. On a body as small as Vesta, it looks like a monstrous pimple jutting from the South Pole, visible even from orbit. But the story doesn't end with Vesta itself. These collisions hurled debris into space on a staggering scale. So much was ejected that entire families of asteroids known as V-type asteroids were formed from the fragments. Some of these pieces now orbit across the solar system, and remarkably, a few even fall to Earth. In fact, around 5% of meteorites found on our planet are thought to have originated from Vesta. Scientists call them Howardite Eucrit Diogenite meteorites, or HEDs for short. Thanks to them, We didn't need a costly sample return mission to study Vesta. The asteroid had already delivered samples right to our doorstep. All this evidence, its shape, its composition, and its debris, paints a picture of a unique object. Vesta is what scientists call a protoplanet, or, more dramatically, a planetary embryo that never finished growing. Let's imagine the early solar system. Billions of years ago, clouds of dust and gas in the protoplanetary disk clumped together into thousands of planetesimals. These rocky building blocks collided, merging over time into the large planets we know today. Our own moon likely formed after one such collision when a Mars-sized planetesimal called Theia struck Earth, throwing out debris that eventually coalesced into a sphere under its own gravity. Vesta began on the same journey. It grew large enough to differentiate, meaning that heavy elements like iron sank to form a core about 220 kilometers across, while lighter materials formed a mantle and crust. Heat from impacts and radioactive decay once kept its interior active, reshaping the world from within. But then, something interrupted the process. Vesta cooled, solidified, and stopped evolving. Why many fingers point to Jupiter? The giant planet's immense gravity likely disrupted the asteroid belt, stealing or scattering the material that could have allowed Vesta to continue growing. In another universe, perhaps, Vesta might have joined the ranks of Mercury, Venus, Earth, and Mars. Instead, it remained a fossil, a frozen reminder of what might have been. Interestingly, if not for those massive South Pole impacts, Vesta might today qualify as a dwarf planet. After all, it once had the mass and internal structure, but those billion-year-old collisions deformed it permanently. By the time they occurred, Vesta was already too cold and rigid to relax back into a sphere. In short, Vesta stands as the last rocky protoplanet of our solar system, a survivor of an ancient era when worlds were still being born. At first glance, Vesta seems bland, a grey, cratered rock adrift in space. But looks can be deceiving. With Dawn's instruments capable of capturing light across many wavelengths, an entirely new world emerged. In false colour images, vast regions appear, tinted red, black or blue, revealing layers of different minerals scattered across the surface. The black material is likely ejecta from large impacts. The reddish areas may be melted rock that cooled again after catastrophic collisions. Each colour tells a fragment of Vesta's long and violent history. But there were surprises too. Evidence appeared of what looked like past flows, channels carved by material that once moved across the surface. This was unexpected. Vesta is thought to be extremely dry, with virtually no volatiles in its crust, so how could anything flow? Perhaps the impacting body itself carried volatile materials which melted on impact and briefly ran across the landscape before evaporating. Then came the discovery inside Marcia Crater, one of Vesta's youngest features. Near its base lay strange pits and depressions, a type of terrain that had previously only been seen on Mars. Scientists call it pitted terrain, and on Mars, it's thought to result from volatiles rapidly escaping from rock when heated. On Vesta, something similar may have happened. Hydrated minerals could have been rapidly warmed by an impact, releasing water vapour that exploded outward and left behind pits. This kind of finding leaves us with more questions than answers. How did hydrated minerals even reach Vesta in the first place? Were they delivered by asteroids, or did Vesta once hold more water than we realised? We don't know yet. And then there's the whimsical side of astronomy. A chain of overlapping craters near Marcia resembles a snowman, one of the more famous images from Vesta. But even this playful feature hides a story. The relatively smooth terrain around it was blanketed by ejecta from the impact, softening the rugged landscape into rolling plains. Vesta, it seems, is full of surprises, small mysteries that invite us to keep asking questions. Dawn spent only a year orbiting Vesta, but the discoveries made in that short time reshaped our understanding of the solar system's early days. Then it was time to move on. Thanks to Vesta's weak gravity and Dawn's remarkable ion propulsion system, the spacecraft achieved what no mission had done before it left orbit around one world and set course for another. The ion engine was slow. It took 4 days to accelerate from 0 to just 100 kilometers per hour, but what it lacked in speed, it made up for in endurance. Over the course of its mission, Dawn achieved a velocity change of 11.5 kilometers per second, shattering the previous record. By 2015, Dawn had arrived at its second destination, the dwarf planet Ceres. But that, as they say, is a story for another time. So what did we learn from Dawn's visit to Vesta? We discovered a world that is not just another asteroid, but a unique remnant of planetary formation. Vesta is a survivor from the solar system's earliest days, scarred by catastrophic impacts, marked by strange flows and mysterious pits, and still holding fragments of a story billions of years old. When we look at Vesta, we see not just a rock in space, but a fossil, a clue to how planets like Earth came to be. And thanks to Dawn, we now have a front row seat to that ancient tale. As we move forward, let's keep asking what other secrets are hidden in the asteroid belt. What other stories wait to be uncovered by future missions? Because in the end, every time we uncover a world like Vesta, we're also uncovering a little more about ourselves and about the cosmic journey that brought us here. Vesta is more than a scarred rock. It's a time capsule from the dawn of the solar system. By studying it, we're not just learning about asteroids, we're learning about ourselves and the forces that shape the world we call home. If you enjoyed this journey, join us again as we continue exploring the mysteries of space here on Cosmic Compass. Until next time, let's keep reaching for the stars.